The next speaker will be my friend Mariami Kupatadze.
Hello, everyone. Can you hear me?
Yes.
Yeah. Hello, I will start sharing and then we'll talk. Okay. So first of all, thanks to the LuxOUG team for giving us the chance to have these virtual days and technical days for speakers and for attenders. Today we will explore the database architecture, which is important to know, and most of the senior DBAs already know about that. Otherwise, administrating the database would be more complicated. But for the junior DBAs, I think these slides will be very useful. This is a small paragraph about me. I am Senior Solutions Architect at FlashGrid, Oracle Certified Master, Oracle ACE Program Member. I'm a co-writer, and we have recently published a book about Oracle called Engage with Microservices, where I'm a co-author, and on the second book, I wrote only one chapter, Oracle Sharding. On the right side, there is my contact information where you can send any questions, and I will be more than happy to answer. The last one is my blog where I share my knowledge about Oracle and Linux. So we'll not talk more about myself. Let's switch to the topic. Objectives are the following. So why I chose this topic is that, like the doctor knows the anatomy of the human body, and based on some symptoms, he or she can analyze where the disease is and cure the actual disease as soon as possible. We database administrators are also doctors for Oracle, and we should know all the components of Oracle database. So let's switch to the next slide. There are three major architectural structures in Oracle database: memory, processes, and storage. So when we think about the instance, we know that it consists only memory and process part, no storage included except during startup phase when it reads the parameter file. When instance starts, system global area is allocated and background processes are started. So this about the instance. On this picture, I depicted this simple architecture, how client and database connection works in a simple way. So when client connects to the database, client of course knows database IP address, port number, and name. And there is a network access, of course, open. Client sends the packet to the database server process, and what happens now is the user process is started on the client side. The corresponding server process, if it's dedicated server environments, a server process is started on the database side, which has a program global area, the area which is not shared by other server processes. And database is responsible to return the result of the client, but it needs some components to work simultaneously and in synchronously. So system global area, background processes, storage are responsible for analyzing the data, parsing the SQL statement, and returning the output to the client. So next slide shows us two types of systems. it's not related to Oracle. Mostly we have such systems in other databases and in other architectures. The first one, simple one from where everyone starts, is non-clustered system, where we have one node which has some sort of storage attached, and database is located on the storage. When database starts, SGA and background processes are allocated to the on the node. So for one database, for ORCL database, we have one instance also called ORCL, and for HRDB we have also one instance which is mostly same name, HRDB instance. But in clustered environment, we have a different configuration. We have at least two nodes. We can have one node cluster, but this is the purpose of one node cluster is that in the future you aim to add more nodes. So mostly when we think about a cluster, real application cluster, we think at least two nodes. They have a shared storage where the database files are located, and when database starts, first instance is started on the first node and second instance is started on the second node. For ORCL database, we have two instances here, as you see on the picture, ORCL1 and ORCL2. This was the simple illustration. Connecting to the database, two main concepts we should know about the connection. First is a connection, which is a communication link between user process and server process, this one. And session is a specific connection between user and instance. Regarding the memory structures, we have two main areas in Oracle database: System Global Area, SGA, and Program Global Area, PGA, which itself are divided into small pools or caches. And we have two types of memory management: automatic shared memory management, where we set memory target to 0, and we set SGA parameters explicitly and PGA parameters, where we define the sizes of each component, globally SGA and the PGA. I should mention that PGA aggregate limit was not available in 11G. It's became available in 12C, and this is actually hard limit of the PGA. And before 12C, we are setting PGA aggregate target to some value, but sometimes our Oracle database may exceed the specified value, because this was just the target, not the hard limit. For automatic memory management, we set memory target and memory max target parameters, which itself will distribute dynamically memory for the SGA and for the PGA. What happens here, when we have bigger sized databases, we mostly do not use automatic memory management. We use automatic shared memory management instead, because in bigger databases, we have bigger memory. So we definitely need to use huge pages when the page table contains bigger size chunks, because it's easier to manage by mostly CPU. So if you use huge pages, you cannot use this type of memory management. You need to set SGA separately. So in the next slides, we will just look through all these pools in details. Database buffer cache. The illustration of database buffer cache can be visible as a grid where we have changed and unchanged blocks. With a pink color, I depicted changed blocks, and this gray color is unchanged blocks. It holds copies of data that are read from disks from data files. Okay. In the shared pool, we have also some areas, library cache and data dictionary cache, and also some other areas. Data dictionary cache holds reference information about database and its structures and users. A library cache stores executable SQL and PLSQL statements. It also contains the statement parse tree and execution plan. For example, when one client runs the statement, let's say, select start from hr.emp. This statement, if it's the first time not in library cache and Oracle needs to hard parse this statement, set up the parse tree and execution plan. This plan is placed in this library cache, and next time when the same user or another user tries to run the same statement, Oracle need only search the corresponding statement in the library cache and use its execution plan. So this is called soft parse, when CPU resources and other resources are more released and easier for Oracle. That's why we need shared pool. Read log buffer is a circular buffer, which means when it's filled, it's rewritten again. It holds information about changes done by data manipulation language or data definition language that contains redo entries later to recover instance in case of instance termination on some or some other cases. So when a client runs, let's say, update statement, this update statement is written in the log buffer. Large pool is used for allocation of big chunks of memory, such as used by parallel query and RMAN operations. Sometimes we use Java code in the database, and we need for this to have Java pool set accordingly. If we use streams, Java pool stores all session-specific Java code and data within the Java virtual machine. And streams pool is not commonly used. Mostly we do not use streams, and Oracle also recommends us to use Golden Gate for application purposes. Because with bigger data, streams is not the good option. For capture and apply, if we still use for some small tables, we need to set streams pool accordingly. For the fixed SGA, this is not changeable. All other buffers and pools are changeable through the parameter. Fixed SGA, it contains state of the database and the instance background processes. It's like a bootstrap section where SGA, which saves information about other parts of the SGA. The PGA is a program global area specific to an operating process or thread that's not shared by other processes, and this is also divided into several areas. SQL work area, this blue one, and the private SQL area. When we have some sort of operations like selecting something and we have order by statement, we need sort area size to use, not we, but Oracle uses. Hash area is used for hash joins, and bitmap merge is used when bitmap indexes need to be merged to retrieve data. Persistent area contains bind variable values. Runtime area contains query execution state. How many rows retrieved so far? User process on the application. So we have in the process architecture, we have user process, database process, daemon, and application processes. User process, as we've described, is started on the client side. Database process is started on the server, on the database server side, and we have two types of database processes: server process and background process. Server process, when user establishes a session, server process is started on the database side and connects to the instance. Background process, as we've seen before, is responsible for reading the data from disk and writing to the buffer and vice versa. Application processes and daemons are network listener, grid infrastructure daemons. So what processes we have in Oracle? To describe the illustration, when a user process connects to the database, server process is started, but how the connection happens? We have another guy here. This is the listener, which listens on some endpoint. This is the IP address of the a public network and some port number, listener port number. When user connects to the listener forwards to the database node. Then the connection happens after finding the server process and allocating the PGA. The connection happens to another link. So why should we know this? When we stop the listener, we should know what effect does it have on the database. If we stop the listener, no existing connection will stop. Existing connections will continue to work because they use separate channel for communication, but no new connection will happen to the database. Let's look through all these required and optional processes, background processes. Database writer writes dirty, so changed blocks from buffer cache to data file, disk, and also reading from here to the buffer. We have N here because there may be several database writers. Log writer, as you guessed, is reading the data from read log buffer and writing to the read log files. And this happens on some schedule when user process commits a transaction. So when transaction is committed, we are sure that the transaction is saved in on the disk, because in previous slide, when we update the block, it may not return to the data file every time because this operation is very heavy and requires a lot of resources. So Oracle delays this writing to the data file, but as we know, if instance terminates, this buffer is cleared, so we need to have that information saved on disk permanently before commit returns the notification to the client that transaction is committed. The information from read log buffer goes to the read log files, and later, if our instance crashes, instance recovery happens automatically by Oracle by reading all changes after latest system change number, and Oracle starts. Another option, another schedule is when log buffer is 1/3 full and before database writer writes modified blocks to disks, or every 3 seconds. Checkpoint process is very important process. It records checkpoint information into the control file and data file headers. Checkpointing is an important Oracle activity which records the highest system change number So when commit happens, system change number increases, so that all data blocks less than or equal to the system change number are known to be written out to the data files. If there is a failure and then subsequent cache recovery is needed, only the redo record that containing changes higher than the checkpoint need to be applied during instance recovery process. System monitor is responsible for performing recovery at instance startup and cleaning unused temporary segments. Process monitor performs process recovery when a user process fails. So when user is connected and something happened, for example, network disruption happened between the client and the database. This user, of course, had some resources allocated. If it changed something, then buffer cache is also not clean and contains changes done by this user, but maybe these changes are not committed even and not ended successfully. And also it may have some logs. So process monitor is responsible for cleaning up, identifying such a process first, and cleaning database buffer cache, which was only the part which was modified by this user, frees resources by the failed user process, releases logs, monitors session idle timeout. Why process monitor needs to see and check session idle timeout? That's when user connect to the database. Mostly we have some idle timeout set by default 15 minutes. And after if the user is not running anything, so is not active for 15 minutes, its idle timeout is passed and session should be disconnected. The connection should be dropped. When the user reruns some statement in the same session, it will get error, and process monitor should clean up or should do all these tasks mentioned before. In lower versions, it was dynamically registering database service with listeners, but in newer versions, now it's done by RECO process, listener registration process, not process monitor anymore. A recovery process, RECO, is used with distributed database configuration. What is distributed database configuration? Let's recall, this is let's say transaction, one part of the transaction is running on the database 1 and another part of the transaction is running on the database 2, and only after that comes commit statement. This mostly is achievable through the database links. But what happens if the database 1 transaction fails? We need to have someone responsible for the task to clean the second part of the transaction on the remote database. This is in-doubt transaction because the first part of the transaction was not finished. So RECO is responsible to connect to the second database several times and automatically connect and resolve in-doubt transactions by rolling back them. Archiver process is optional because it's not always available. If you have your database in archive log mode, only then you will see archiver process. It copies, of course, redo log files to the designated area, storage area after log switch, and can collect also if you have data guard, can collect the redo data and transmit to the standby destination. Why do we need to archive this? Because as we know, log files are circular. So when one is filled, it's switched to the another, and when last is filled, it's switched to the first one. And if first one is not archived, it's rewritten. If you are not in archive log mode, it's rewritten and you will lose some data. For point-in-time recovery purposes. Database physical structure is a control file, is a really important file which contains database file location, online read log file location, temporary and tablespace file. I mean, it's data files actually, temporary and files. Also contains information about database name, system change number, database ID, backup information, but it's limited in size and backup information may be rewritten. So we need to have a recovery catalog for saving backup information in the database instead of control file. Data file contains actual blocks and actual data. Redo log file, as we've talked, contains changes like update statement, delete, create, and any other DML and DDL statements inside the read log file. Read log file may not contain the data if you run some direct pass operations or some operations that has indicated no logging, but sometimes this operation may still go to the read log file because maybe your database in data guard and the forced logging is enabled. We have two types of parameter files, as you know, a system SP file, and which is binary, and parameter file, which is text file, which contains all the parameter information about the database, instance specific parameters, the memory values like SGA target, PGA target, and so on. Also contains information about the control files, control underscore file, parameter contains that value. And several other parameters which is critical for the database. Control file, data file, and current read log file is critical for the database, but we can recreate the parameter file. We just may lose some parameters and we need to retune our database, but it's still recreatable. Backup file is the copy of the data file. Archive log is a copy of the read log file. Password file contains information about administrative users. Why do we need this file? Because when database is stopped, we still need to connect to the database. And if the password is saved inside the database, then we won't be able to connect because it's down. So we need some external file for that. Alert log and trace files. Also, incident and core files mostly are for Oracle support, and these files is very critical for the database administrator, and we regularly check and also have some notifications and alerts set to watch this file. It contains chronological order, the log files in a chronological order, and when something happens, this is the first place where we check what's happening in the database. Now we've talked about physical, now let's talk about the logical structure and also see where they intersect. In logical structure, we have database. Database consists of several table spaces. Table space can be located on several data files if it's small file. This file is physically located on some storage. Table space consists of several segments. Segment actually is a table, but it's not abstract thing. This is a table index. It's a partition table, then several partitions are several indexes and so on. If we have some size for the table, for example, 20G table, and we need to add more rows, then we need to, Oracle needs to increase segment by some size, and this some size is extent. Extent is a combination of Oracle data blocks. So let's see another illustration of the same segment exists in table space, as we know. Segments are collection of extents. Extents are collection of database blocks, and database block itself is a collection of file system block, operating system block. This illustration depicts several things together. First of all, we see that we have table space, two types of table spaces, small file, which is default, and you can have multiple data files if you want to increase the size of the table space, and we have big file. This is not default. We need to indicate keyword big file during the creation. We can have only one data file in big file table space, which size is 128 terabyte maximum. In small file, we have several files which consist of database blocks. I've chosen 8 KB. This database block cannot be changed without recreation, but you can have additional table spaces, additional sized blocks, but default cannot be changed. Here I've chosen 8 KB, which is most common for most of the databases. Several combination of blocks consists extent, and as you see, one extent is located in one file, another extent is located in another file, and the sum of these is a segment. So we are not sure when one file goes offline what amount of data we lose from the table, let's say. Maybe all the extents are located in this file, or maybe none of the extents were located to this file and only this file and some other files. Important table spaces, we have system, which is always online when database is open and contain the data dictionary tables for the database. SysAux table space is the auxiliary table space to the system table space, and this is a centralized location for database. Also, Enterprise Manager repository saves the information inside this table space. Temporary contains temporary data and may contain data for sorting operations. If you remember, I've mentioned sort area size, which is located in the PGA, it's called work area, which is used sorting operations. And when you run some select statement, which has ordered by clause and there is a big amount of data, and this data should be placed for sorting in the sort area size. If this size is too small, then our data goes to the temporary table space. So on the disk, and sorting operation happens there. So that's why our order by may be too slow if our sort area size is not big enough. Undo contains undo segments. So for the insert statement, undo is delete. For the delete statement, undo is insert. For the update, undo statement is the same update, but with the reverse changes. So to recall the phase when there is instance termination, what happens? First of all, database comes into no mount state, reads a parameter file, then goes to the mount state, reads control file. Then it reads data file, system change number, checks that it needs recovery because control file knows that the database are not up to date. It reads the redo data until the end, applies these changes, and if there are some changes that was not committed and the redo still contains this one, then undo is necessary at the last phase to undo all the uncommitted transactions. If you have any questions, please feel free to ask. If I will wait, and also I have some small questions, like 6 of them we can test on our environment to see how it looks like. Let me know, and meanwhile I will share my another terminal, another screen. Do you have any questions? I think this topic was not new to everyone, and I hope if you don't have questions or you already knew these things, just let's play with the database.
Sorry, Mari, I have some problem with Zoom. My screen became black again.
Oh, okay. So while you are solving your problem, I think there is no question in the chat, so I will just continue my question and answer section. So the first question can be how to check parameters in Oracle database. What are ways for that? The first one is to show the parameter, for example, for SGA max size. Let's connect to the database and run this statement. This is my parameter. This is my value. Or another version of checking is checking dynamic view with our parameter and selecting and filtering by name SGA max size. How to set size for database buffer cache. As we know, there are some parameters that can be changed dynamically, or some are static parameters and they cannot be changed in the memory. So we have two scopes, right? Memory and SP file. If we are changing parameters that cannot be changed in memory, then we need to explicitly specify scope SP file. Otherwise, the default is both. Both means memory and SP file. So after setting this, outer system set and DB cache size, we're setting 300 megabytes. It's altered, but actually not active right now. Database needs to be restarted. I will not restart now, not necessary for the illustration. How to check where my data files and relog files are located. So let's check this through the data dictionary view. This is DBA underscore data files. We have another also. Let's check that the file name column contains that, or select name from the data file. If we need to know members of the log, then we check in the log file. So simply, if we want to know where my control files are located, then we can check in dynamic view $control file. Or checking the parameter control file underscore control underscore file. As we talked, SP file and parameter file also contains information about the control file as a parameter. So this one. How to check what is the maximum PGA usage after instance startup. So when instance starts, we have defined some parameters for PGA and SGA, but this may change for a while, and it may be not necessary that much size, and you need to adjust um, according to your environments. We have several statistics, dynamic views with changes every time we can monitor, or also we can do this not only through this way, but from the cloud control or some other tools to check our memory parameters and statistics of the Oracle. For example, this one will show us what was the maximum PGA allocated in this database after instance startup. This is instance specific. I'm checking on the real application cluster, but actually I'm selecting only instance related information, and will show you the information about this, the first instance. Show parameter, check which instance is that. The first one, or the simplest one, how to find what is the OS process ID of my DB writer or log writer. We can run some commands from here, and if we want to run Linux command, then we need to write this exclamation mark, and we just check processes and grab the DB writer. So this is our database writer 0, the only one database writer for the ORCL database. ID is this one. And for the log writer, ID is this one. So background process contains the name inside, so we can easily identify where is the log writer, where is the database writer, and so on. And some of the processes are restartable if you kill suddenly, or some other process, for example, during the out of memory, the kernel may kill some processes, and one of them may be the database writer or log writer, and it may cause instance termination. So be careful with killing processes. For example, if I kill system monitor, you know what happens, right? Instance will be terminated. Okay, I talked too fast in this session. Let me know if you have any questions, not to the session related, maybe some other questions related to Oracle.
I have one question, but just for curiosity.
Yes.
What is the often static parameter that you forget doing to the installations?
Which parameter, static parameter?
What is the most common parameter you forget to set during your installations, static parameters? For example, in my case, I very often forget to set convert to set up data guards. So when I realized that, I said, oh my gosh.
Oh, really? Yes, and you need to restart the database. Yeah, I've had the same situation several times. Where I work, actually, we do not do too much manual stuff. We did a lot of automatic scripts. So mostly we add automation, so we do not forget. That's why.
Yes, that's good.
Everything is scripted.
Automatize scripting. So once you
Right.
fix it, you fix forever.
Right, that's right. So,
any more questions? Let's see. Sorry, my Zoom hung twice. once when doing the last presentation with Zabala, and now with you. When you finish, you start to asking. I was trying to reply you, but I don't know if you heard my voice.
Oh, okay. Now it's perfect.
So thank you so much, Mari. I hope I pronounced your name correctly in the beginning of the presentation. That time I correct the name. Perfect.
Thank you too. Everything was really great. I attended other sessions and they were really interesting and very, very good stuff. So thank you again.
Thank you so much for everybody, and also the speakers from today and the previous days. And tomorrow we'll have the last day of fun on LuxOUG Virtual Tech Days this week. So maybe we'll have more events in the future, but this week will end up tomorrow for us. So thank you very much for everyone. See you tomorrow if it's possible. Bye-bye.